Hello students, today we are going to discuss first assignment which is related to hashing. Hashing data structure we have already seen in the theory part where we know that hashing is one of the searching mechanism which targets to reduce the time complexity, and most of the time it will try to retrieve the item in big of one amount of time. But yes, again, there are many disadvantages. We already know whenever the hash collision occurs, we have to deal with some collision resolution strategy so that the element can be inserted in the hash table. So let us see the title. So consider telephone book database of n clients. Make use of a hash table implementation to quickly look up client's telephone number. And then they have asked us to make use of two collision handling techniques and compare them using number of comparisons required to find a set of telephone number. So if we look at this practical, this aims to create one telephone database. So this database will basically store the telephone numbers of the client, and then whenever the collision is occurring, so we know that we can have two clients with the same telephone number. So whenever a collision occurs, in that case we have to use any two collision handling techniques to reduce the searching time. We have to see which collision resolution handling technique can be used. Okay, and now let us see like how this output can be visualized. Consider this as a sample telephone database. Basically, this is going to be a hash table. So if I consider the size of hash table as 10, the indexes will be in the range of 0 to 9. That is total 10. Now, as we have already seen in this particular program, the input which will be entered by user will be the telephone number of a client. So we know that whenever we have to store any entry in this hash table, what we require is we have to apply the hash function. After applying the hash function, it will return you the hash index where that particular number has to be stored. Now, whenever no collision is there and each of your phone number is mapping to the unique index in the hash table, then everything seems okay. But that's not always true. Sometimes it's possible that two or more mobile numbers they will return same hash index. So this scenario we call as a hash collision. And in order to deal with hash collision, there are many collision resolution strategies. So in this practical, I will tell you that if I use simple collision resolution technique, that is linear probing, how can we get the numbers with the same hash key in a same table? So that is what we are going to discuss. So let us go to the program. So here is program. Now we know that we always use object oriented paradigm to write the program. So this is my class called as hash, and they have asked us to implement two functions like insert and display. One more can be added, that is search function. So if you understand insert, then immediately you will be able to implement this search function as well. So this is class called hash. As I have to store mobile numbers are of 10 digits, and that's why I have used this long integer data type here. And of course, for storing them in the hash table, I have declared this array called max, and the max size defined here is 10. So what this line will do, this will create a hash table ranging in the indices from 0 to 9. Now this is my constructor of the class called hash, and what this constructor is doing, this constructor is initializing all the locations in your array to 0. So initially all the array locations will be initialized to 0. And now I have three member functions in this class: hash function, insert and display. So hash function, what it will do? It will take telephone number as an input, and it will apply hash function on that telephone number. So it will return you one key or one index where you have to store that number. Okay, so the hash function returns the target key, okay, as output. Then we have insert function and we have display function. Insert will insert keys in a hash table by applying hash function on them, and display function will display the hash table. Like this will be a switch case driven program. So whenever you press 1 for insert, it will ask you to enter a mobile number which you want to insert, and once the number is inserted, you may press 2 for displaying the contents of hash table. Okay, now let us discuss definition of these functions one by one. First function, as I told you, is hash function. What it takes as input is, it takes mobile number as an input, which is of long integer type. And I have taken like variable a. So what this function returns? It returns the hash index. So very simple hash function, we know generally we use mod. So return a mod 10. Okay, so whatever mobile number is passed here, so it will apply mod 10 on that, and whatever target index is there, it will be returned to the column. Now, second function, which is very important for me, is this insert function. What we are doing in insert function? Now, in insert function, we will read the mobile number from the user, and by applying hash function on that mobile number, we will try to insert in a hash table. So it is asking user to enter the mobile number, which you have read here, and then it calls this hash function so that you will get the index where you have to insert that number in a hash table. Okay, now just forget about this while condition. I will tell you it later. Now very simple thing is there in a hash table. Now I will again tell you about this particular hash table. See, initially our hash table is empty, nothing is there, right? For example, now when the user enters his mobile number, let us say 9960263614. So if I apply mod 10 on this mobile number, it will return me index 4. So what it means is that mobile number I have to insert at the fourth location in a hash table, right? So now if the function returns 4 and if this array index location is free, okay, if this array index location 4 is empty, then I will directly store my number at that particular index, right? So if ARR of index is 0, it means the target index where you want to place your number is empty, is not occupied. In that case, you can directly insert your mobile number over there. Okay. Now to keep the track of how many numbers I have entered in a hash table, I have taken one count variable which is initialized to 0. Now every time I insert one number in a hash table, count variable is incremented by 1. Okay. So when your number is inserted in a hash table, we are breaking from the loop. We are breaking from the loop. Now again user may give the choice to insert a number in a hash table. And just imagine that one number with hash index 4 is already entered here. Now if I again enter second number for which hash index is again 4, then what should happen in linear probing? We know. Let me move out from this slideshow. Consider that I have inserted my own number here. Now user has given another mobile number. Okay. Let us say user has given 9823. Okay, I will write it here so that you will understand. I have some another number 98234565 and then 34. If this number I have to insert in a hash table, then what we do is we apply hash function. So if I apply hash function like number mod 10, it will again return me 4. But now what is the scene here? The index location 4 is already occupied. So what I have to do in this case? I have to linearly probe down to search for the next empty memory location in the array, right? So now here if I probe down this table linearly, then I come to know that index number 5, location number 5 is empty. That's why I will insert my number here 9823 say 456534. So this number will be inserted here because this is the next empty location in the array, right? Now let us see how to tackle this condition using the code. So if array index equal to 0, you directly copied your number in that particular memory location of array, and you have incremented count by 1 telling that number is inserted in the hash table. Now just we have discussed that sometimes it is possible that the hash index which is written by the hash function is not available. Then it will not go in this if part, it will come in the else part, and it will check, what, which is the next empty location. Okay, which is the next empty location. Now when you are linearly probing it down, two possibilities can happen. we know that when we reach to index number 9, it is possible that first three locations like 0 to 3, these four memory locations are still empty in the array, and now you are there at index number 9. So we know in this case what happens, again our search starts at index 0, right? So we have to again jump at index number 0. So it goes in a cyclic manner to see whether any empty location is available in the array or not. Exactly to handle this condition, I have written if index equal to max minus 1. So when your index reaches to 9, then again you have to restart from 0. So this is to handle this condition. I hope you have understood. This is to handle this condition when you are there at index 9, and if these four locations are empty, of course you should again start searching the empty location from index number 0 onwards. So to tackle this, this is written if index equal to max minus 1, initialize index equal to 0. Otherwise, index plus plus. Okay, if index is not equal to max minus 1. So if you are not there at 9, consider that this case we have. So if you are there at 4, it will simply increment the index by 1, and it will go to 5, and it will insert your number over there. Okay, so it will insert your number over there. So why we have written this thing? If we are at index number 9, and again if we have to start from index number 0, so for making that index 0, we have written this code. If this is not true, then simply what we have to just increment index by 1 to find out which is the next empty location. So just we have seen that after 4, 5 was the next empty location. So our number will be inserted over there. Okay. Now, after inserting the numbers, you know that what is capacity of hash table here? Capacity of hash table is 10. So already we have discussed that count variable is initialized to 0 every time I insert element in the hash table, the value of count variable is incremented by 1. So when I am inserting numbers in a hash table, I have to look for these two conditions. While index is less than 10 and count is less than 10. Now why we need to deal with count also? Because we know that there will be a time when hash table will be full. Now when hash table will be full, whenever all 10 memory locations of hash table are occupied, then hash table is full. So if count equal to 10, then we simply display the message that hash table is full. Okay. So please observe this condition. That is what? While index is less than 10 and while count is less than 10, we are repeating this code. Now it will come out of the loop when count reaches to 10, and when count reaches to 10, you will simply display one message that hash table is full. Now you want to display the contents of hash table. See, displaying contents of hash table, it is as good as you are displaying contents of the array, because we have taken one array only. The data type of that array is long integer. Why? Because we wanted to store the mobile numbers which are 10 digit long, right? So I have applied this for loop for displaying the numbers. So for I equal to 0, I less than max, I plus plus. What you have taken? You have taken contents of array into one temporary variable. Now, if temp equal to 0, if temp equal to 0, it means that now you recall that initially when we started the program, we initialized all contents of array to 0. So if still value of that temp is 0, it means that you have not inserted any element at that location in the hash table. So it will simply show you index. Suppose whatever index, say 2. There is no element at 2. So it will show you 2 here followed by dash 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 null. So this is just for making the feel of hash table. That's why it is shown like arrow null. And if it is not 0, it means what? There is some number which you have already stored in the hash table. So how it will display? See out. First of all, it will display that index followed by value of temp. Temp is what? The contents of array we have already taken in the temp variable. And of course, in if also we have given new line, so that all the numbers in the hash table will be displayed on the new line. So these are two very simple functions in the hash table, one for insertion and another for display. So let us look at the main function. So this is switch case driven program wherein we have two choices, insert and display. right? So we know how to write a switch case. So case 1 here is insertion. And as we have already defined the class for hash table called hash, okay? So we create one object of that class here called h, and then to call the insert function, I have used h dot insert, and again display is called by using h dot display. And unless the user hits choice as 0, the loop will be continued and you will be able to insert numbers in the hash table. Okay, and at the end there will be written 0 because the return type of main is integer here, right? Now let us test the output. So here I go, here I run my program, and let us test some output. So now it is asking me to enter the number. So I will press 1 and I will hit enter. So it is asking me to enter mobile number. So I enter my own mobile number here and press enter. Now let us see in what format it is showing me the output. So for display, I press 2, and see, this is the output. So let me increase size of this output screen. So now you can see here, the hash table size is 0 to 9, that is total 10. I hope you understood the meaning of this now. It was just for giving you a feel of hash table. So as no other numbers are stored, so remaining locations are empty, and the only location where we stored our number was 4, so it is showing my own number here. Now let us test for one more cases. Okay, so I again choose a choice for inserting a number in a hash table, and I press 1, and let us say I entered number which is again, colliding to the fourth index, and let us see what happens. Now if I press enter here, again it has inserted my number, and let us see how it is storing that number in a hash table by entering choice number 2 for display. And here we go. See, now this has linearly probed it down, right? So when the two numbers which collided to the same hash key, that is 4, were found in the table, what it did, it probed that location linearly down, and then the location 5 has stored our next collided number, that is 9877653554. Now we have also handled the condition, that is when we reach to index number 9. Ideally, you can't proceed further because the hash table size is over. But we know that we have again caused this loop to start with index number 0, right? So even though when you try to insert number, okay, I will show you that case also. Consider again insertion. Now I give some number which is, mapping to index number 9, and this is the number where it should be mapped. It should be mapped to index number 9. Let us test it by display. So you can see the number is mapped to index number 9. Now again, if I insert a number which is mapping to the same hash index 9, so whether you will display the message that hash table is full? No, because in the table we can see that 0, 1, 2, 3, then 6, 7, 8, they're still vacant. So ideally, again, it should start searching for empty location from index 0 onwards. And let us see whether it is doing like that or not. Again, I insert the number, but again, I have to give the number which is, returning me 9 only, right? So this is the number given by me, and let us see by using display whether it has inserted it at correct place. Yes, it has. You can see when the index number 9 was occupied, again it has started its search from 0th index, and this is how the number is inserted in the hash table. You can also try for, like, if you insert the number, okay, I will do, but I will not enter 10-digit number. I will just give some number which is returning me index number 1. Okay. So I just give 1. This is just for testing purpose. I want to test whether it shows us the condition where hash table becomes full. So please excuse me for giving wrong input, that I am giving 1, which should go in first location ideally. Again, I insert which number I have given. I have given 2. So we'll go at index number 2. Again, I insert and I give 3 so that it will go at index number 3. 4, 5 is already occupied, right? So I give 6, which will go at index number 6. Again, I insert and I give 7, which will be inserted at index number 7. And the last, again, I insert the number and I enter 8 so that it will go at index number 8. Now, if I display the hash table, surprisingly, you can see that now all the locations are occupied. Please excuse me excuse me, pardon me, as I told that I have not given valid mobile numbers here, but it is just for testing purpose. Now, the main thing. Now, if I want to insert a number, if I try for that, it will ask me to enter a number. Let us say I enter some number as say some random number I have given. Let us say it is colliding to index number 4. And now if I hit enter, it should show me some message, right? So it should show me some message. What went wrong? 987645. Okay, so here we have entered one extra character, but fine. So if you enter such number, it will show you that the hash table is now full. Okay, so this is how you have to run the program for hashing, and this is very first, first collision resolution technique, which we call as a linear probing. And I hope with this you have understood how to apply linear probing. So you all will try for this now. Thank you.